So the topic of this presentation is on implementation of customized functionality using S function. I try to cover S functions, type of S functions, usage of S functions, and flags in level 1 Matlab S function, input and output arguments, and how we execute different levels of S functions, and structure of S function and file, how to write S function, and example of S function model. As I told you in first lecture, that a Matlab function block is used to design static nonlinear system where we have an expression y equal to fu. But if we have a more complex system, dynamic system, we want to design with more complicated differential and difference equation, we prefer S function. The programmed S function, in fact, S function is a customized Simulink block where we write the code in the S function or program a S function using Matlab language, using C, C++, Ada or Fortran. So the programmed S functions behave in the same way as your already existing blocks available in Simulink library. S functions have their own programming structure. Now, this S function is basically a part of user-defined function block library. The first is S function blocks. It provides access to S function. The S function named as S function named parameter can be a level 1 M file or a level 1 or 2 CMax file S function, or a level 1 M file S function. We use S function block. S function block is used to create level 1 M file S function. A level 2 M file S function is an M file that defines the properties and behavior of an instance of a level 2 M file S function block that reference the M file S function in a Simulink model. The level 2 M file S function block is available in user-defined function library. Level 2 M file S function block is again available in user-defined function library. It allows to use a level 2 M file S function in a model. If you want to create a level 1, use S function block. If you want to create a level 2 M file S function, use level 2 M file S function block. S function builder blocks create a CMax file S function from specification and C source code that we provide. In fact, if you are having a little experience in C programming, it is more preferable to use this S function builder block. Yes, S function example block it contains the example of M file S function, C file S function, C++ S function, Ada S function, and Fortran S functions example. So this S function example block contains example of M file S function, C file S function, C++, Ada, and Fortran S functions example. S function provide a powerful mechanism for extending the capabilities of Simulink. A user can create own blocks. S functions are Simulink block that can be programmed by a user either as an M file or a max file. S functions are basically of two types, either M file S functions or a max file S function. It is a computer language description of a Simulink block written in Matlab, C, C++, Ada, or Fortran. What I told you is you have to write a language code either in Matlab, C, C++, Ada, or Fortran. It can accommodate continuous, discrete, and hybrid system. In fact, nearly all Simulink model can be described as S function. The blocks that are existing in our library can be understood as a S functions. It enables user to add on blocks in Simulink model. You can create your own customized blocks. S functions are compiled as max file using the max utility as per other max file. If you are using a C language, then you have to execute this using max utility available within Matlab. Now, the types of S function. I told you there are two types of S function. Either it can be implemented using Matlab scripting language or C, C++, and Fortran. If a S function is written in Matlab programming environment using Matlab function, it is called M file S function. If S function is written in C, C++ programming environment, it is called CMax S function. S function written in C with the later 2 needs to be compiled first. If you write a S function with C or C++, you have to compile first in order to produce a shared library loaded by the Simulink engine, while a Matlab S function will be interpreted and executed during simulation. This is to understand the types of level 1 and level 2. This is Matlab S function. This is max S function. In case of Matlab S function, we have level 1 S functions, level 2 S functions. In case of max S function, we have C max S function, C++ max S function, and Fortran S function level 1 and level 2. So basically there are two types, mfile S function and max S function. So both we have a level 1, level 2, C max S function, C max, C++ S function. Now the usage of S function. S function is most widely used to create custom Simulink blocks. It can be used for a variety of applications, such as to implement algorithm in S function, for incorporating existing C code into simulation, used to simulate complex dynamic system. Any complex system can be modeled using Simulink, used to communicate with external device in hardware in the loop application, for adding new general purpose block to Simulink, for describing a system as a mathematical set of equation, to build a general purpose block that user can use many times in a model, varying parameter with each instance of the block, using graphical animation. In summary, S functions enable to create custom Simulink block in a situation where user cannot model custom functionality using the existing Simulink block. It enables to utilize existing Matlab C or C++ code that model custom functionality. So it is used to create custom Simulink block. Now, in order to understand this creation of S function block, you have to understand the structure of a Simulink block. And each block within a Simulink model consists of a vector of input U, a vector of states, and a vector of output Y. The state variable may consist of continuous state, discrete state, or a combination of both, hybrid system. They are both states. The mathematical relationship between the input, discrete state, and states are given as, for output equation, this, continuous state equation, this, discrete state equation, this. In S functions written in Matlab programming language, the Matlab S function Simulink partition the states into two space, continuous state and discrete state. Simulink partition the state into two parts, the continuous states and discrete state. The first part of the state vector is occupied by the continuous state, and the discrete state occupy the second part. In case of a block with no state, X is an empty vector. But in other programming language written S function, max file S function, there are two separate state vectors for continuous and discrete states. How S functions work? S function consists of a series of basic subfunctions. I think before coming to this, I will try to show. Yes, steps for writing S function. There are basically three steps for writing S function. The first step is setting of initial parameters, update of states, and the third step is output signal evaluation. S functions, level 1 S functions are implemented as Matlab functions, where the structure of a Matlab function is keyword function followed by output argument, for output argument, sys, x0, string, ts, with the function name or file name of the function, input argument t, x, u, flag, p1, p2, and this p1, p2 are the additional parameter that we can supply to the S function block as a through the dialog box. Flag is basically a very important parameter that tell the Simulink to perform the task. What kinds of tasks Simulink have to perform? U represent a column vector of block input. X is a state column vector of corresponding S functions block. T is current simulation time. F is the name of the S function block, S function file name. So this flag is basically an input argument which takes integer value, and there are 6 integer value that it takes. Yes, it takes 6 integer value. The first is corresponding to flag value 0. The Simulink perform the task initialization, and the syntax of the Matlab function that it call is this sys x naught string ts. This is here again MDL. Yes, MDL initialize size txu p1 p2. This is sub function which it call continuous state update. The flag value corresponding to the flag up is 1 continuous state update, and the syntax of the Matlab sub function which it call is sys equal to MDL derivative. This sys is the output argument that it returns during each value, each times the flag is used. Corresponding to this initialization, it returns sys as a state vector, as a vector of 6 values. Continuous state, it returns single output argument corresponding to this derivative function. Discrete state update, it returns this MDL update function. Compute the output, this MDL output function. Calculation of next sample time, and termination of simulation. This is, so there are 6 flag value. As I told you, there are 6 flag 0 corresponding to initialization, and the S function sub function it call is MDL initialize size. Corresponding to flag 1, the S function sub function is MDL derivative, and it is used for computation of update of states. And this corresponding to flag 2, it is your S function sub function is MDL update, and it is used corresponding to discrete states update. Corresponding to flag value 3, MDL output is your this the sub function called is MDL output, and it is used for computation of system output. So if you look at the structure of a, this is your basically the first line in your level 1 Matlab function. It indicates your input argument as 4, sorry, input argument as xu flag p1 p2, and output argument as sys x naught string ts. So depending upon this flag value, it assigns the tasks to perform using switch case statement. This t represents the current value of simulation time, x is current value of S function state vector, u is current value of input vector, flag is basically an integer which indicates the task to be performed. P1, P2, these are optional parameters which a user supplied through your dialog box. These are 4 output arguments which are written by the function. This sys, it is a multi-purpose output argument. The definition of sys depends on the value of flag. I told you corresponding to each flag. If you look at each value of flag, yes, corresponding to each value of flag, corresponding to flag 0, this is your S output argument. Corresponding to flag sys, corresponding to this flag 2, this, and so if corresponding to each value of your flag, there is different output argument. And it returns these 3 input argument. X is your initial value of S function state vector. The number of initial value is equal to the number of continuous state or discrete states in the system. str is a placeholder output argument, and it is set as an empty matrix, and ts is your sample time. It is basically a combination of 2 things, sample time and offset pair. Offset pair is normally taken as 0. In case of your first sub function, your sys argument returned is basically consist of this number of continuous state, number of discrete state. It is a vector which consists of number of continuous state, number of discrete state, number of output, number of input. Then is set 0. F is your it indicates direct feed through, and G is number of sample time. So this is the value of argument SYS. Now, if the flag is 1, then SYS is a column vector of derivative of standard variable. If flag is 3, then SYS is a column vector of output variable. X0 is initial state value at flag 0. This STR is reserved for future. TS is an array of 2-column matrix containing the sample time and offset. Offset is normally taken as 0. There are 6 types of requests that Simulink perform, each of which is designated by an integer number. Flag value is 0, 1, 2, 3, 4, 9. In Matlab S function, flags are used for indicating the current simulation stage. S functions code call the appropriate function for each flag value. These are the sub functions which are called by this corresponding to each flag value. 0, 1, 2, 3, 4, 9. Corresponding S functions, flags, and stages of simulation that we proceed. Now, if you look on S function, it can be a system with no state, having only continuous state, and having only discrete state. In a S functions, 2 functions are mandatory. This MDL initialize size, it is called every time, and this computation of system output, it is called every time. If you have a system with no state, no continuous state, no discrete state. In case of a system with no state, flag 0 and 3 are used. Flag value 0 is for initialization, flag value 3 is for computing output. And flag 1, 2, 4, 9 are set as empty string. In case of a continuous system, what we do, flag 1 is used, which is used to update continuous state. So the flag used for continuous system is flag 0, 1, and 3. And for a discrete system, the flag used are 0, 2, and 3. This is the S function action corresponding to this flag 0, it initialize. Corresponding to 1, it update continuous state. Corresponding to it update discrete state. Corresponding to flag 3, it computes output. Corresponding to flag 4, it compute next sample time. And flag 9 is used to terminate simulation. Yes, if in case of this first flag value, if we look at Matlab S function structure, it consists of a top level function which is defined by function definition line, and it contains a number of 6 sub functions, each of which is called corresponding to flag value. Within the first function, MDL initialize size, the first command that it uses is size, sim size, to extract a structure variable size. And in this, there are 6 important and essential templates that are used. Number of continuous state, num continuous state, number of continuous state of the block, number of discrete state, number of output, number of input, and this size dot direct feed through is used to set your direct feed through, and it is set to 1 if there is a direct feed through, otherwise it is set 0. Direct feed through means that block output is a function of input. A block for which the output is an algebraic function of input has direct feed through, or where the states are explicitly specified in a system. Number of sample times offset pair must be at least 1 even for purely continuous S function. Now we come to the templates, M-file function and demos. In case of level 1 M-file S function, there are 5 templates, and it is always recommended to follow the structure and the convention given in the templates. You start with the templates available with the thing. So in order to look at different kinds of template, there exist several template file separate for continuous time system named as csfunc.m, discrete time system dsfunc.m, that can be copied to work folder. If you want to work with a continuous system, start with the template this for a continuous system. If you want to work with a discrete system, start with the template this one. If you want to copy or edit any template, either type edit rather than type as function template this. So it will open as function demo. So this is the demo for of as function for continuous system. Demo of discrete. The first line, this is your first line, which is function definition line. The input arguments are, output arguments are this. This as function template is basically for discrete system. There are 6 values of flag. In case of discrete system, I told you flag 0 is used for initialization, that is later on. MDL update case 2 for output, and for update is for discrete state, and case 3 is for output. These S functions are called. The first command in this your initialize size is sim size. This command is used to create a structured variable size. Then values are assigned to this structure variable size. The essential and frequently used template 6, number of continuous state, number of discrete state, number of output, number of input, direct feed through, number of sample time. And then this sim size command is used to return the output to a as argument sys which Simulink use. The 3 output argument x naught, it is your initial condition, str and ts. This is a 2 column vector. This is set as 0 offset, and this is your sample time. This is. If you look at this, there is a direct feed through in this case. So states are explicitly specified here. In case of a discrete system, number of continuous states equal to the number of row in square matrix A. So that is the command we use, size A1, to tell number of number of discrete state in the system. This is used to give number of output. Number of output equal to number of row in matrix D, and the number of input is equal to number of column in matrix D. So this is the template of continuous system. Discrete system, and the flags which are used here is 0, 2 and 3. Now look on this is the template of continuous system. Function definition line, switch flag, case 0 and case 3 is used. Case 3, case 1 is for calculation of computation of or update of discrete states. So these in discrete system, flag value is 0, 2, 3. Here it is 0, 1, 3. Again, when you look at this, this is corresponding to this matrix A, B. It is already declared in the template. A, B, C, D. So corresponding to this, again, this is your first command to create a structure variable. Number of continuous state we tell it. Number of discrete state 0. Number of output 2. Number of input 2. Direct feed through there exists. Sample time is 1. Sim size we return it to the SYS argument, and zeros initial condition, and this sample time is 0 for continuous system. So this is the function that we call for computation of state as x derivative equal to ax plus bu, y equal to cx plus du. This is for this is an example. This is already available template for multiplying a scalar by 2 times 2. Here there is no state, no continuous state, no discrete state. So the if you look at on this switch flag, and the flag value used is 0 and 3, and the rest of is set as empty string. The state which are not used is set as empty string. Then within your MDL initialize size subfunction, the first command that we use to create structure variable, we define essential and frequently used member of template. Number of continuous state 0, number of discrete state, number of output -1 dynamically sized, number of input -1 dynamic feed through. You have to specify number of sample time 1, and then output SYS MD. So the task performed by the task performed during flag value 0 is initialization. This is the task that is performed. Here you have to specify the block sample time. You have to set the block sample time, number and size of input and output port, number of input and output port, direct feed through, 6 essential members of the template. Calculation of next sample hit corresponding to flag, calculation of output in measure time step, update of discrete state, and this is the way how the S function simulation cycle works. Initially, in the beginning of the simulation, the flag value is set 0 automatically, and Simulink call the initialize function. After it, in the first simulation step, the output argument 3 is used to compute the output. Firstly 0, then 3, then 1, 2 continuous state or discrete. 1, 3, 1, 2. 3, 1, 2. Then in the next simulation step, the same process is repeated. You are getting my point? Firstly, your 0, then 3 in the first simulation step, and then 1, 2, and in the next simulation step, the same process is repeated. This is S function simulation cycle. Yeah, there are 3 things that you have to remember. When we call this initialize size function, here what we are doing, we are setting the initial parameters. Firstly, statement size equal to sim size x except default parameters template size, which is a structure array. Then 6 essential and frequently used members of templates are called. Number of continuous state, number of discrete state, number of output, number of input, direct feed through, number of sample time. After the members are set, the template size can be returned with the statement sim size. Your output argument, this the size is argument is specified, and output argument tsxr string is also returned. Then the continuous and discrete states are updated using the corresponding subfunction MDL derivative and MDL update respectively. The updated state variables are returned in SYS argument. And in step 3rd, output signal evaluation. The function MDL output is called, and the output signal is returned in the argument SYS. This is implementation of S function. How we implement the same template that I described, no need. Template and file S function. The template consists of a top level function and a set of skeleton subfunction, each of which correspond to a particular value of function. The first function that you define through function definition line, function sys x naught str ts. This is top level function, and that you call in each corresponding to each value of flag, that is your subfunction. The top level function invokes the subfunction indicated by the flag. The subfunction, which are called S function callback method, perform the task required of the S function during simulation. Corresponding to each flag value, each subfunction perform task. It is recommended that the structure and naming convention of the template be followed when creating M-file S function. This makes it easier for others to understand and maintain M-file S function that you create. These are the template which are available corresponding to level 1 M-file S function. Continuous time CS function. Go in your command window, type edit this name. It will open the template, this one. Inherited sample time. Again, go in command window, type edit this name. It will open inherited sample time template. Unit delay template. Again here, this times 2. Used to implement scalar level. This is level 1 Matlab file S function template. This you type edit S function TMPL in your command window. Edit. This is your S function level 1 S function template. General Matlab S function template. With Matlab S function, you can define your own ordinary differential equation, discrete system. I told you it is used to model dynamic system, ordinary differential equation, discrete system, or any other algorithm. A general form of M-file S function is this is general form of S file function. This is the name of the file name of the S function. In case of a function is always saved with the same file name as the name of the function. This is description of flag. 6 flags: 0, 1, 2, 3, 4, reserved for future. This 5 and 9. Switch case statement. Initialize. MDL derivative. MDL update and output, and then terminate. Sorry, get time of next variable hit and this terminate. As functions example, if you go in your user defined library and if you take this S function example block, and when you double click this S function example block, what we find, it contains Matlab file S function, C file S function, C++ S function, Fortran S function structure. If we double click on Matlab M file S function, it will open level 2 Matlab file function and level 1 Matlab file function. In case of level 1 M file S functions, it contains times2, limited integrator, unit delay, inherited sample time, continuous time variable step, Matlab file. Already available templates in level 1 M file S function 5, and this is your level 1 general template. If you double click on any template, it will open its template available. Now open Simulink, and in Simulink go in user defined library, and in user defined library, if you this S function example, S function example block, Matlab file S function, C file S function, C++ S function, Fortran S function. Matlab, if you double click on this Matlab M file function, level 2 Matlab file S function, level 1 Matlab file S function. If we double click on level 1 M file S function, it open all the templates available. This, if you click on this is already existing model. Firstly, we take example of this times2. It is simple. This times2 template, what we are doing, we are multiplying a scalar by some value. If we double click on this S function block, it opens 3 field. In case of edit field named S function name, we enter the names of S function. S function's parameter, in the edit box labeled S function parameter, we enter the optional parameter P1, P2 that we supply it to the. This is the name of times2 function, and only flag 0 and 3 is used. Flag 1249 is set as empty, and Here in case of MDL output function, here the output is multiplied by 2. When you close it and if you click on this C file as function, continuous, discrete, data type, multiplication, this is basic CMax template, and this is detailed CMax template. Basic CMax template. If you click it here, detailed CMax template. C++, Fortran as function. So these are the various as functions available under as functions example block. Now I will take an example of times 2 block. This is modification of times 2 template to compute the step response of a first order system. The step response of first order system is basically it is given as 1 minus exponential minus t by tau. Tau is your time constant, which I assume it here 5. This is the modification of template. Name of the function is step basic RC. This template here used is number of continuous state is 0, discrete state is 0, output is 1, input is 1, there is a direct feed through, sample time is 1, X note, this is null, str is reserved for future, ts is set 0 0. This is your MDL derivative not used, set as empty. MDL update not used, set as empty. Then MDL output expression is written here for first. Close it. See, this is basically the step response that we compute it using transfer function, and this is a time domain implementation. 1 minus this 1 minus e raised to power minus t by tau, and this is S function. S function, what we do, we firstly modify the template whose name is step underscore basic underscore RC, and then we drag these blocks from user defined library into this model window. We double click on the block, and in the edit field name, S function name, we enter the name of the S function. The parameters are yeah, otherwise it give error. Folder in the same folder. And here we have to just give that name. This establish a connection between your Simulink mode S function and your M file function M file. So this we close, and then I set this simulation time as 40 and run. So it is executed. This is a step response using transfer function block, step response using this time domain, analytical time domain, and this is using all three. So S functions work. Now we try to provide the additional parameter. Instead of this time constant as fixed value, we provide it from the S function, this S function parameters. So
whenever we want to create a thing, I think we have to go to the template.
Yeah, you have to more. It is always recommended to follow the structure and naming convention of the template. So in your command window, the name of the template you want to modify it, press enter key and put it into your work folder. And this work folder should be in your current. This is again the same. The only change is here, instead of 5, the time constant RC is given in your this part. Close it. This start. Now in your command window, firstly we have to provide this R and C.
Excuse me, sir. Hello. Hello. Ma'am, do you have any doubts? Yes, ma'am. We are having any doubts. Yeah. Just you can ask.
Hello, ma'am. I'm Astha Vyas from GEET Jodhpur, GEET Institute of Engineering and Technology. My question to sir is that in convolutional encoding, when we are performing it in the Simulink, when we are deciding the soft decision decoding of that particular thing, how we are analyzing for the different transmission code rates, the data bits. Like suppose for 1/2 code rate, 1/4, 2/3. So how we are deciding the soft decision bits for that in soft decision decoding?
In case of this, you have to just give your sample rate in your S function template coding, number of continuous.
Sir, it would be like helpful like if you can show an example of two different rates, and can you show that like how we are deciding the bits, soft decision bits for that decoding?
I have no example for that.
Actually, say, sir, is giving you the basics. When we are doing some research or something, we know more about it, isn't it? So you can just try this. Now you just see that there is. We understood that there are templates and you can go and modify your program and you can implement it. This is just a model key how to do it. Simple programs you are doing. When you want to go into depth and do it, you can just try it from your end. Hello, ma'am.
Hello.
Actually, say sir is explaining you the basics. Okay.
Level 1.
So the level 1, and he is telling you about the different format in which you can implement it. So what I feel is, say everyone have their own problems. Okay. So I don't think so any expert, if you ask them, it is very difficult for them to just tell it. So now it is our thing, when you are inside a field, you know that very clearly, you have to think about it, how to implement it using that.
Okay, thank you.
So so when I'm also thinking, like I'm just thinking of my problem, how to implement it. So this is a basic thing. So sir is telling you the format and the template and the process how to implement it. So we have to just think on what is our problem and how will we fit our problem into it.
Okay, thank you. Thank you, ma'am.
So this is again the same problem. Here uh, uh, the additional parameter a, r, and c is supplied through the edit box name as function parameter dialog box. And in case of your template, these three variables,
तो आपने जो x फंक्शन लिखा था उसमें r and c वैल्यू डिफाइन नहीं
ये पहले केस में नहीं डिफाइन की थी।
ओके, पहले केस में नहीं था,
हाँ,
सेकंड केस में
मेंशन
किया था।
हाँ मेंशन किया है
तो यहाँ
पहले
आके वो पैरामीटर
देने थ्रू डायलॉग बॉक्स
ओके, डायलॉग बॉक्स
as function dialog box. If we click on this as function dialog box, the two fields are important. As function name, specify the name of the as function, and if you have any additional parameter that you want to specify, provide it through this dialog box A, R, and C. So
from where will we give the value now?
now from the command window,
Okay,
from the command window, from the command window, and it this A, C. So specify A, R, and C. Suppose A we specify A equal to 10. So now we go in your yes, already specified. So it is executed. Now if you look this is so in this case the as functions additional parameters are supplied through the dialog box. No, the programming template, yes, it is a specified template. Yes, templates are available for, I told you, suppose you have a system with no continuous state. So you go in times two template. Times two template means just you modify your own things. And if you find there is a system, I will take an example of this is basically an example of a first order system. So first order system can be modeled using transfer function or state space approach. And if it is an example of a continuous system, go in continuous system function template simply. There is no need to write your own template when it is existing. The only thing is you have to modify the template as per your requirement, as per your functionality. And if you find there is a discrete system, so you modify the discrete system template. That is this is a structure of a M file template that I already explained. Structure of M file. Deconstruction of a, if you look at the times two template, the first line is your function definition line. After the first line, the S function file is split into different case determined by the flag. There are 6 flag values, so a switch case statement is used. And in case of this times 2 template, only 0 and 3 is used, so 1, 2, 4, and 9 is set as empty string. The last 2 lines of, you can take this as a times 3 template also to catch exceptional case when there is a error has occurred during simulation. For case 0, initialization, the function mdl initialize size invokes the sim size command. Firstly, the sim size command is used without argument. Sim size, it creates a structure variable. Then we specify the parameter. Then again using the command sim size, again we create a structure variable as the argument, which actually translates the value in the structure size into a raw vector. It then initializes the state ordering string and sample time. For case 3, you can take 3 here. Steps in S functions simulation. Insertion of S functions into Simulink model. How we use this S function. Firstly, open your untitled model window. Copy your level 1 M file S function block into it. Double click on the S function block. In the S function blocks name field, edit or enter the name of the S function file, and then a connection is established between them. Specify the input and output, run your model. I just take other example of level 1 M file. This is again the same problem. Name of the S function here we specified in this block, and if you look at this S function, this function definition line, function name, here it is a continuous system, so we use this derivative, and a function in this is called here, this. This function R and C is specified here, this. So this is your step signal of, and this is your step response. This is one of the example that is taken from a famous book, Mastering Simulink. Here again times 2 template is used, and there are two input signal, and is this first input signal, second scale. This is computed. So the name of this S function is input argument, output argument, this switch case statement, then first function MDL derivative empty, no continuous state, no discrete state, this MDL update, this is only set. Let us to create this model, we firstly drag this S function block. In template, we write specify the name of the S function. Then we give two input signal through this, and we visualize output here. Run the simulation. You can change constant 1 input, step 10 final value. So 10 square plus 1. This continuous state template is used to create this M file S function. Matrix A, B, C, D is specified. The flag 013 is used, and the 249 is set as empty string. This function SYS in this initialized size is called number of continuous state 1, number of discrete state 0, number of output 1, number of input 1, direct feed through, and through. The meaning of this thing is, if you have a state system, state variable should be explicitly specified in terms of output. x derivative equal to ax plus bu, y equal to cx plus du. So there should be direct state should be clearly specified. Or in case of a no continuous state, the output should be an algebraic function of input like y equal to ft. So it should be that. Zero. Yes. This. Yeah. In case of continuous system, we use this update of continuous state. So this is this, and the output is computed here. This tail out. This. When you run it, this is state space block, transfer function block. This is your S function blocks. So this is implementation of S function, continuous system S function. Let us take an example of second order system. Again, we take this continuous system template. The matrix A, B, C, D is specified here. It can be entered through the dialog box also. So A, B, C, D flag is used as 0, 1, 3, and 249 is set as empty string. The first function is invoked. First function MDL initialize size is called. The first command is used to create structure variable. The 6 essential members of the templates are called: number of continuous state 2, discrete state 0, number of output 1, number of input 1, direct feed through 1, number of sample time 1, continuous state, and discretes. This is your transfer function block, CS function block. So and so all these are the example of level 1 M file S function block. Level 2 M file S function block. Again, in case of level 2 M file S function block, different templates are available. The first 5 template of level 1 are already existing here. Times 2, unit delay, continuous, limited integrator, inherited sample time, and this. So level 2 M file S functions are continuous time variable step Matlab M file, inherited sample time, limited int. These all are the templates of level 2 M file S function. And there is 2 more template, basic template and general template. This is your level 2 M file. First 5 models of level 2 M file S functions are same as those of level 1 M file S function. In case of first problem, we take the step response of first order system. The same can be implemented using level 2 M file S functions template, basic times 2 template. If we double click on level 2 M file S function template block, it displays the structure of level 2 M file S function template. To create a level 2 M file S function, we simply copy the template that Simulink provide and edit the copy as necessary to reflect the desired behavior of the S functions you are creating. Means you copy the template and edit it. Level 2 M file S function consists of a setback of callback method that Simulink invokes when updating or simulating the model. Level 2 M file S function blocks contains more functionality than the level 1 M file S function block. The callback method performs the actual work of initializing and computing the output of the block defined by the S function block. How to write S function block that I told you? Firstly, write the S function block in Matlab editor window using M file. Save the function exactly as the name in the Matlab work directory. Open Simulink and open a new model window. Click the user-defined function of Simulink library browser. Drag the S function block to new model window and click on the block to change its name exactly as function name declared in M file. Then this block will work as the user-defined block, which will behave as the other existing block in Simulink library. General structure of Simulink block. Conclusion of this. The power of the S functions in creation of customized block for a specific application has been presented. You can create your own custom Simulink blocks. It depends on the user, which kinds of functionality you want to implement in level 1 or level 2. Two different approach, level 1 and level 2 are taken here. Systems with any complexity can be modeled using S function block. Dynamic system, modeled with continuous state, discrete state, hybrid system. M function method cannot accept additional parameter which limit the use of the S function, which limit the use of M function, not S function. Sorry, it is basically, if you look at M function, whatever the input arguments you supply in your function file, can you provide more than this input argument? No. Here, in case of S functions, you can provide additional argument using the dialog box of the S function block. So that is all about level 1 M file S function block. Now, after it, we come to level 2. S function builder block. This is your S function builder block. If you find there is a user which is not having C programming expertise and want to use this level 2 M file S function block, then it is recommended to use this S function builder block. In case of S function builder block, the first thing is you copy this S function builder block from user defined library, and in the name, S function name field here, you enter the name of the S function that you want to create. Suppose we give it S. Simply I write a simple example, sum. Then this S function builder blocks have these different pane initialization data properties, libraries, output, continuous, derivative, discrete, building information. If you look at your problem, it can have only no state, continuous state, discrete state. So simply if we take to add two number, then what we define, we come to this data property pane, and in case of data property pane, it is used to initialize ports and parameters of your S function block, and here we enter input variable, suppose A, then add second variable B, go in output, here suppose C, then go this on this build information pane, build, click on this all right, yes, let's start. Yes, three different files have created. The first file is s underscore sum. This is the name of the s function that I specified in the dialog box, followed with .c. It is used to create C code of your s sum, generated a wrapper.c and tlc file. You click here on this. This is your generated code. Yes, code. It generate code. No, go here. You in this part specify star c equal to star a plus star b followed by semicolon. Save it. Go in your copy this s function builder block. And these three files are here. This is wrapper.c in your current directory. This .tlc, which is for running your this model in accelerator mode, and the model is s function name is
सर वैसे मेरा नाम सर अभी सर उसके बाद
go in max. Already exists. Yes, yes. It means that is problem. Inbuilt compiler LCC or that problem. Uh, mix setup. इसमें compile problem. There is a problem of compiler. I can show it on other laptop that is with. Yes. Max executable file is not created. So this is the problem.
Which compiler we have to install?
It is already inbuilt LCC compiler. I can show it on other system if you say. That earlier I have also executed this model, but not able to run.
This is the procedure that
Yes,
you
yes.
first go there and take the function,
Yes.
then enter the name, and after that you put
Yeah,
the variable.
and in case of a continuous system, in case of a continuous system, this continuous derivative in or libraries. So if you want to include any external library, so this.
Is there help available for this S function also in demos?
Yes. So this is all taken from the help. Firstly, you specify the name of the S function in S function name field, then specify input and output port parameters in data property pane. Initialization is basically if we have a system with continuous and discrete states. So then we specify this, and the number of continuous state or discrete state is equal to the in number of initial condition is equal to number of continuous state. Data property pane, you can add input port or delete number of input and output, or you can shift it up and down. Then input port you specify here, output port parameters you specify, and then libraries output. Just simply build your block continuous, and then it creates 3 files: your s function dot c file, wrapper dot c, and tlc. In go in wrapper dot c file, you add your your functionality, and then go in your MATLAB command window.
So when we change that, after that should we save that in some location?
It should be in the current directory.
Okay, it should be in the current directory.
If it is not in the current directory, it will give an error always. These, then you run it.
Once you build it, it will go in the current directory and it will be built there. So
Yeah, it is built there. Then you have to go in your command window, MATLAB command window.
Okay, command window.
Then you have to write max. Max के बाद
Okay, so
पहले .c file, and then you have to write dot wrapper dot as function. Then it will run.
then how will we bring it to simulate?
This S function is created. S function builder block is used itself in the simulator.
Okay, yeah.
This S function builder block is used as that in a. This is S function builder. Just like your level 1 M file S function, it is used. S function builder block is used. In place of this, you can use level 2 M file S function. S function builder block, or we can use this C function builder block. So there are number of templates for level 2. This S function example blocks contains only example.
Okay.
S functions builder is for max, and S function block simply is for level 1, and level 2 is this. You take this block. If we click on this S function 2, this is the template of level 2 MATLAB S function. This is your primary function times 2 MSFC and times 2 block. It call a function setup block. This function has only one input argument block, and it returns no output argument. Within this function setup block, we initialize the basic attributes of your S function block. Here we specify number of input and output port. So this level 2 M function block is based on object-oriented methodology. We specify number of input port 1, number of output port 1. This to set functional port properties to dynamically inherited. We specify block sample time. Block dot sample time. We specify this. We call this block dot register block method. Only one. A level 2 M file function must include at least 2 callback method. One is your setup function, and other is your output function. If you look at level 1 function, we call initialize and output. Here, the first function, this is setup block. It is used setup block, setup, and then this is 2 times. This is output. Here, block output port 1 dot data. This is 2 times block input port 1 dot data. Let us save this template on the desktop. Times 2 desktop. Save it. specify the name of we saved it on desktop, and the name is yes. And if we want to write it for this is a step response for first order system using level 2 uh, level 2 S function. If we look at level 2 S function, this is structure. Primary function, name of the level 2 S function, setup block. It calls a function setup. Within this setup function, you have to define the basic attributes of your block. How many input it port, number of input and output port, sample time of the blocks, block direct feed through, dialog parameters, and this. Yeah, this. And in the function output block here, 1 into this. This is written as this way. You're right. In case of this level 2 M file as function block, this continuous time variable template. If we look at this template, in fact, we look at general purpose template rather than level 2 M file. This is your general template for level 2 M file as function. The Matlab S function is written as a Matlab function with the same name as the S function. Replace the name of the template with the name of your S function you want to create. Start with this level 2 M file basic template. This is annotated template. It should be noted that the Matlab S function is very similar to level 2 CMax S function. The first thing within this S function is your function setup, and it set the S functions block basic attributes or characteristics, number of input ports, number of output ports, dialog parameters, option. Look at level 1 M file S function initialize function. What we do there? We specify 6 essential templates, 6 essential members of the template. Number of continuous state, number of output, number of input, sample time, and so this is more having more functionality. Register the number of port, block dot number of input port 1, number of output port 1. Set the port properties to be inherited or dynamic. It sets the sample time according to your input signal. Then specify the attributes of this your input port. Block dot input port data type 00. Complexity, real or complex. Block input port 1 data type complex. Override the output port property. Similarly, block output port properties. Block output port 2 dot data type. This register the number of parameters, the parameters that you want to enter in the S function dialog box. 3. Number of continuous state. A number of discrete states are not initialized in setup block. Number of continuous states are initialized here. Sample time blocks. This you have to see. This sample time is a combination of two things. The 0 and offset is 0. Continuous sample time is 0. Discrete sample time offset positive number. Inherited sample time always -1. And variable sample time -2. This sample time is for continuous sample time 0. Option then specify the accelerator that used with PLC, sim state compliance, and block dot register block method. At the end of this function setup block, we call register block method. This block dot register block method for set input port sample mode. There are two input arguments. This is one, this is other. This is function handle, and block register block method set all this set output port data type, set input port complex signal type, register block method. So the and process parameter initialize condition start, and when at the end of this we have a block dot register. Yes. This is end function setup. Function, primary function, setup, call function setup, specify the basic attributes of the parameter. If you look at level 1, it is very small. Level 2, there is more functionality. Then these functions you have to call here, corresponding to check parameter, process parameter, input port dialog box, sample. So dwork is basically it is used to store discrete states of the vector. It is a discrete state vector used to store discrete function initialize condition block. So this is the template of a level 2 general template. You can look on this any template. Inherited sample time. If you look at inherited sample time template, inherited sample time is C -1 0 block sample time. Block sample time is -1 0. Name of S function block, setup, function setup, number of input port, number of output port, and this block sample time. This. So there are a lot of level 2 S function template that you can use depending on your choice. So any queries, please?
Model centers, do you have any queries? So anyway, okay. If anyone have any query, you can switch on your mics. So thank you, sir. It was really a very interesting lecture, because now you now those who are in the initial stage, you will not know it. But when we are doing research and things, in first lecture also I showed you a windmill. So that was an animation where the programming was done along with the animation. So when you want to bring animations and all, you cannot do it like in MATLAB directly. You will be using some other like say C or some other language you will be using. So those programs, if you want to bring it here into Simulink, you have to know this S function. So this is a very important thing. So those who are working on it, like now anyway you understood the concept, because before I have also worked with S function. I simply used to put the block and write something, that's all. But now we understood there is a template and this is how we have to write and this is how we have to program. So we can start with a simple program and you can try it, so you'll understand the concept. Or sometimes when you're taking some animations and you're putting also, you can just go and see what type of template they used and what they have programmed. Now you know that how to look into a program which is already existing. So first of all, first step what you can do is you just go and see the programs which are already existing, just try to analyze it, then you will understand the concept and then you can try to implement your problem into that. Okay, so this was really a very useful lecture, and I thank sir for coming such a long distance and delivering a wonderful lecture. And thank you once again to everyone. Tomorrow sharp 10 o'clock we'll start with the optimization lecture. Okay, thank you, sir.